Now, number 15. With diboron through dicarbon, the repulsive interactions between the sigma 2s orbital electrons and the sigma 2pz orbital electrons drives the sigma 2pz energy above the pi 2p energy. Yes, we've already discussed this. That's just a restatement of something we've already discussed from another point of view. And it's a result of the increasing electronegativity and the nature of the pi 2p or sigma 2pz and the sigma 2s. That's the reason this, but it's this interaction that is going to be for the early part of the piece here, of the p block elements. As we've seen over here, the energy of the sigma 2pz is greater than that of the pi 2p for that reason, because of those repulsive interactions. So that is indeed true. Which one was this? Number 15. Yes. That is true. Now, number 16. The magnetic properties of molecules can be explained with the valence bond model. Well, that is obviously false. We've already discussed that because it does not. This is not revealed with the valence bond model. That's why we needed to come up with a molecular orbital model to explain those and other features. So this is blatantly false. Now, number 17. When there is trigonal bipyramidal electron pair geometry for the central atom, the lone pair electrons always occupy equatorial positions. Okay, that was another mouthful, but it is actually true. That is going to give rise to the minimum repulsive interaction. So I will just simply state that it is true for all for all systems with 5 electron pairs. You're going to have trigonal bipyramidal E-pair geometry. And with those, if there are any of those are lone pair electrons, and there can be up to 3 lone pair electrons with such systems, those electrons are always, the lone pairs are always placed into the equatorial positions. I won't bother to draw the picture. You can play with the models. Now, that one is true. So that was number 17. Now, number 18. Bond dissociation is an exothermic process, and bond formation is an endothermic process. Well, really? What does exothermic and endothermic mean, and what does dissociation and formation mean? That's sort of the opposite of what it means. Bond dissociation, the bonds, you have to perform work to pull those electrons apart. So that means you're going to have to put work into it to dissociate into a bond. You have to, and so it's the opposite. Bond dissociation, you have to put work in. If you have to put work in, or energy, which is the ability to do work, into the process, it's endothermic. And whereas when a bond forms, it is doing work. The system is going to the potential energy of the bond is gaining. You're gaining, and therefore, it is an exothermic. Energy is going to be released when the bonds form. And so this is the opposite of true, which we would say false. Okay, so number 18. Now number 19. An atom with 5 electron pairs will have square pyramidal electron pair geometry? No. That is not. There is only 5 cases you have to know. And they are, for 2, it's linear. For 3, it's trigonal planar. For 4, it's tetrahedral. For 5, it's trigonal bipyramidal, and for 6, it's octahedral. There's nothing about square pyramidal anywhere in that mix. So that's not one of the 6 cases. This one is definitely false. Number 20, with the Lewis dot model, electrons are shared in a way that provides a stable closed shell electron configuration for each atom in a molecule. Yes, this is the heart of the Lewis dot. This is the triangle that explains everything. Every atom in a molecule, with the exception of group 3, which is going to form one pair short of the closed shell, and then it's going to give Lewis acids. Every atom here, hydrogen, for closed shell structure for the first row, has 2 electrons in it. It has that closed shell electron configuration. Carbon has, now with the second row, we have 8 electrons give rise to that closed shell electron configuration. So I have 2, 4, 6, 8, and that is where the octet rule comes from. So I've got the closed shell electron configuration for all the atoms in the molecule. Again, here, I've got 2, 4, 6, 8 with nitrogen, and again, 2 for each of the hydrogens. So this is indeed going to be true. It is going to be the minimum requirement. There's going to be exceptions, the aforementioned exceptions being the group 3, which form 2 electrons short. They have not a closed shell electron configuration. They have a closed subshell, the P subshell, which can accommodate 6 electrons. That's filled. And so that's what's achieved only for the group 3A. Now, as we get to the heavier elements, we can expand and accommodate more than that closed shell electron configuration. But the very minimum requirement is met for all the outer atoms. They're all going to get that stable closed shell electron configuration. So that is the heart of the Lewis dot model. So number 20 is true. Now, number 21. Bond strength increases as bond length decreases. Yeah. The shorter the bond, the stronger the bond. The longer the bond, the weaker the bond. So that is another way of saying that very thing. So this is true. And that is the true-false questions on this practice midterm.